Hi everyone, Wayne Williams and Samantha Fulton here from Profunda Analytics. We're not fans of long intros in these webinars, so we're going to keep this one very short. First, who are we? We're a small startup by two BI veterans. We have an extensive background in data processing, data quality, and advanced analytics. Our main industry experience is in healthcare and manufacturing. And we're completely fascinated by advanced interfaces, especially those involving voice control and virtual reality. Our business has two areas of focus. The first is advanced analytics. Here we deal with things like treatment efficacy, causal relationships, behavioral analytics, text mining, etc. We also build a lot of task-specific and in-process systems. We're now extending these capabilities further using voice control. Our other area of focus is self-serve analytics, where we focus on training, architectural design, and online support. We use Dundas BI for advanced analytics work, and either Dundas or Power BI on the self-service side, depending on requirements. Today's agenda is to demonstrate our voice-driven analytics system. Many people think voice is just an alternative to keyboard and mouse controls, and some think of it as just a gadget. We don't agree. We think it has the potential to completely revolutionize how BI systems are designed, built, and used. Let's have a look. This is the opening interface. Even here, you have to change your way of thinking. In reality, there is no opening interface in a voice-controlled system. You can start your inquiry anywhere and go anywhere, as we'll now demonstrate. Pretend that you're an executive with a bicycle company. While visiting clients, a couple of them mention that they've seen a recent spike in quality problems with one of your top-selling bikes, the Touring 1000. You promise that you'll check into it. Here is how you would do that. Go Interface Customer Returns. Change Series 1 Touring 1000. Add Series Bikes. So what are we doing here? First, we're going straight to the heart of the issue by checking customer returns on the Touring 1000. But we're also doing something equally as important. We're comparing it to the overall return rate for all bikes. However, in this business, returns don't tell the whole story. Customers also perform in-store warranty repairs. Let's have a look at those. Carry data, customer repairs. As you can see, there's a huge spike here for the Touring 1000. Notice also how we got here. By using the simple phrase, carry data, we've switched measures but otherwise kept the same comparison against the all bikes measure. Next question, what's wrong with the Touring 1000? Explore Series 1 Customer Repair Details. As you can see from this top 5 components chart in the upper right, the main problem seems to be with the rear derailleur. I'm not a fan of this type of word cloud in the lower left. I'm sure Dundas will improve it going forward, but it does clearly show that the top two or most frequent words are broken and pivots. So it appears we're experiencing broken pivots in the rear derailleur. Let's have a quick look at the return details. Carry data, customer return details. Here, we see that the top reason for the Touring 1000 returns is a quality problem. And the word cloud shows that the term or the phrase rear derailleur is once again at the heart of the issue. Next logical question, are we experiencing the same problems in manufacturing? Carry data, production rejects. Add series bikes. There are no real changes here. Let's check rework. Carry data, production rework. This is more interesting. We did have a problem with production rework, but we seem to have fixed it right around the time that customers started reporting problems.
Did we try to fix something internally only to push the problem further downstream? Let's find out. Explore Series 1 Product Routing Changes. We did make a routing change back in the middle of 2007, but it doesn't seem to have anything to do with derailers. Besides, it's 9 months too early. Let's check components instead. Carry data, product component changes. There it is. We swapped in a new type of rear derailleur back in March, and then customers started reporting problems soon after. We now have enough to have a conversation with operations, but we need to know how urgent all of this is. Has it impacted sales? Carry data, sales. There seems to be a significant drop-off right around April, so it does appear that we're adversely affecting the Turing 1000's reputation. We need to put a stop to that. Carry data, open orders. Hold all. We've just put all the open orders for the Turing 1000 on hold. More important for this demo, we've completed our first voice-driven scenario, and I'd like to draw your attention to a few things. First, as you're all aware, most existing BI systems are a collection of dashboard silos. That is, each area or department has its own set of dashboards. Each dashboard also has its own pre-planned set of navigation paths, meaning you can go from A to B and say B to E, but not from, say, D to R. We also can't cover our entire data pool, in part because we can't navigate to every nook and cranny of it. So what do? We cover the stuff that we think is important, both in terms of interfaces and data. That's not a bad solution, but let me tell you a quick story and the reason why voice control is not just a gadget replacement for the keyboard or mouse. I'll keep this story short so no one fires at Canon. About 20 years ago, I built some reporting and operational systems for a manufacturing company. The owner was thrilled with these systems and rather bizarrely offered me a position as its VP of operations. I just as bizarrely accepted it and soon found myself in charge of 2 manufacturing plants, a warehouse, and 235 employees. Here's the thing. The systems I built for that company were good. In my naivety, I thought that a VP operations could use them to run his or her department. But when I became an actual VP, I found that I only used those systems 1 or 2 hours a week, mostly for monitoring. The other 98% of my time I spent either trying to solve problems or make improvements. There was no way to predict what those would be, and definitely no way to predict what kind of data navigational path they required. What I really wanted was something like this, where I could enter the data pool at any point, go to any other point in any sequence, and where my mind, not the interface mechanics, dictated the steps of my analysis. You may not realize it on such a small sample, but that's what I just demonstrated to you. We started our inquiry with customer returns because it was a customer that complained to us. But we could have just as easily started it with a dip in sales or at any other point. And we could have uncovered what was wrong in any sequence that we felt appropriate. This flexibility is what users really need. Now let me show you one other ingredient of navigation. Go, interface, sales. Delete all. Add series Canada. Explore Series 1 product category. Note what we have here, a breakdown of Canadian sales by product category, exactly what we'd expect. Note in particular this pie chart, which shows a percentage breakdown in sales for each category. Carry data, gross margin. So now we're looking at gross margin for Canada. But watch what happens when I navigate to product category from here. Explore Series 1 product category. As you can see, the charts have changed to show gross margin instead of sales. Notice also that this stacked area graph has automatically replaced the pie chart because it is better at showing gross margin contributions over time. The design point here is that there are multiple potential views of many entities inside most companies. Those views may need to change based on where the user is coming from, or perhaps even the user's role, because all of that affects the context. That is, asking for product category breakdown when looking at sales data is inherently different than asking for a product category breakdown of, say, production costs. All of this leads us to a completely different design model. Instead of building interfaces to play a specific part in rigid, pre-planned structures like this, we design each interface on its own as a standalone black box with a public API that exposes the parameters it accepts and the views that it offers, where any interface can call any other interface in any order so long as it passes sufficient information to allow the new interface to configure itself. Isn't that a lot harder to do, you might ask? It's actually easier because 90% of the code can be put in one standard interface, which acts as a parent of all the other interfaces. All you have to worry about are these little bits here that are different, which are mainly the visual components. That means that you can actually build these systems more quickly than using the traditional approach. It also means that you need to use voice control. Why? Because only voice can handle so many possibilities. Without it, you'd have to put scores of navigational controls on every interface. Okay, enough about navigation. Let's see another advantage of using voice, the way we can amplify the power of each individual interface.
Go Interface Sales. Delete all. Add total. Add series large customers. Add series Mountain 200. Add series Internet. Change series 2 Canada. Change series 3 Black. Change series 3 Retail. This may not seem like such a big deal, but consider the following. Each of these lines is completely independent of the other. The first one is a grand total. The second involves a customer group for Canada only. The third is very specific, one product, one color, sold only through the retail channel. And the fourth is an all sales for the internet channel. Each line is at a different level of the sales hierarchy, one with no filters, others with 1, 2, or 3 filters. Given that there are 9 potential filters per line in this scenario, this would require a lot of manual controls without voice. Let's see what else we can do. For starters, we can affect all lines at once. Change all Germany. Delete all. Add all Canada. What we're doing with this last command is creating a uniform starting point from which we can then create variations. Change Series 1 Internet. Change Series 2 Bikes. Change Series 3 Components. Change Series 4 Medium Customers. Individual control of each series is great, but sometimes we also want to look at top-bottom groups. Delete all. Add top 5 product. Add top 3 salesperson.
Add bottom 4 salesperson. Add top 1 territory. Note how, when you ask for the top 1 territory, it actually identifies the entity in question, the Southwest Territory. We can take this a step further. Delete all. Add top 1st salesperson. Add top 2nd salesperson. Add top 3rd salesperson. Add top 4th salesperson. We can then manipulate all these, and the identified entities will change. Change all clothing. Change all bikes. When we reapply the filter, the system reapplies the top-bottom question to identify the correct entity. The only problem is, setting up these grids is a bit cumbersome, so we allow users to take a shortcut. Reduce all bikes. Save template. Delete all. Apply template top 4 salesperson. Change all bikes. This allows users to save their favorite analysis matrices and then just apply them with a single voice command. Remember when I said that doing all this without voice would require a lot of screen controls? Here's what we'd require so far. As you can see, we need at least 15 screen controls to this point, and there's another 10 or so functions we haven't covered. Let's show you one of those. Delete all. Add series Australia. Add series Canada. Compare series 1, 2. This function creates a side-by-side comparison of a sales breakdown for Australia versus Canada, where we can see such facts as Australia favors the internet over the retail channel, whereas Canada is the opposite. In fact, Canada receives very little sales through the internet channel. Australia doesn't sell to very large customers, whereas this is Canada's top customer group. And so on as we scroll through the comparisons of salespeople, product categories, colors, sizes, top and bottom products, top and bottom customers, and so on. Keep in mind that this comparison could be done for any series that we create in the preceding line chart, including comparisons at different levels in the sales hierarchy. For example, we could compare the performance of one salesperson to the top 3 salespersons as a group. Go back. Delete all. Add series Garrett Vargas. Add top 3 salesperson. Compare series 1, 2.
As this comparison shows, Garrett seems to be avoiding very large customers, whereas the top 3 salespeople focus on them. Garrett is also underselling the colors black and silver, whereas these are the 2 best colors for the top 3 salespeople. What's really exciting about this type of comparison is that it's only scratching the surface. As you know, both Microsoft and Dundas have embraced the statistical computing language R, Using voice, it becomes easy to access this advanced functionality through simple voice commands, commands that can reference any data point that you see on screen. Okay, let's switch subjects now and talk about voice technology. Here's a walkthrough of the basic model. A user starts by speaking into the microphone, which is recorded by Dundas. Dundas relays the voice commands to the Google Speech API in the cloud. As you may or may not know, the Google Speech API takes a bit of a shotgun approach by returning its 5 best guesses to Dundas as to what was said. If you think about this for a moment, that's really all it can do. With all the different voices and accents, and the enormous number of words in the English language, all it can do is guess. Dundas then sends these best guesses to SQL Server. SQL Server contacts the client database and figures out what the user meant. This gets relayed to Dundas, which then generates the correct visualization for the user. And yes, all of this happens with the kind of responsiveness you've seen in this demo. Out of all of this, this is where the magic occurs, in SQL Server and the client database. This is where the world gets shrunk from 1,000,000+ words to words or phrases that matter. For example, if I say add series to Google, it might come back with add series, end series, Antares, as in the 15th brightest star in the sky, as series, or at series. But out of all of these, the database knows that only add series can be correct. This is especially true with respect to things like product names, customer names, etc. Only the database contains the legitimate terms, which is a lot smaller universe than what the Google Speech API must contend with. Now, I'm not going to lie to you. This is a lot more complicated than I'm making it out to be, but it's also extremely effective. Let me show you. What I'm going to do now is just fire off a barrage of add series commands using different data entities. I'm going to focus on data entities because there are so few commands, they aren't a challenge. But the phonetics of the data entities vary tremendously. Also, in our test database of 20,000 customers, there are lots of phonetic collisions. So let me show you how well the system handles this variety. Go back. Delete all. Add series Linda Mitchell. Add series Gillian Carson. Add series David Campbell. Add series Amy Alberts. Delete all. Add series small customer. Add series medium customer. Add series large customer. Add series very large customer. Delete all. Add series Valley Bicycle Specialists. Add series Retirement Activities Association. Add series Superior Hardware Distributors. Add series Discount Bicycle Specialists. Delete all. Add series Product Size 38. Add series Product Size 52. Add series Product Size XL. Add series Product Size 50. As you can see from this demonstration, the system has no problem understanding you, and in fact is far more accurate than Siri, Cortana, etc. To take this a step further, even if Google Speech API sends back 5 guesses that completely misinterpret your commands, our system will use the phonetic patterns in those incorrect commands to compensate and still find the correct command. If it can't, your last line of defense is an override mechanism.
Because I want to talk to you throughout this next segment, I'm going to leave the microphone off and demonstrate another feature, the ability to type your commands instead of using voice. We'll start with the show override command. These are all the voice overrides currently in place. When the system hears the value shown in the voice value column, and it can't match it to a valid command or data element, it gives you an opportunity to provide a replacement value shown in this column. For example, here you can see all the replacements for add series, for variations of add series. We've got N series, N series, as series, at series, and they all map to add series. Note also that you can provide different overrides for different elements of speech. So down here we have, these are all command overrides, but you can have interface overrides and parameter overrides. And you'll understand what this means shortly, but it relates to the grammatical structure that we've created inside the system. Lastly, overrides can apply to all users, or they can apply to individual users. Now let me give you an example. If I were to say type add trucker, the system won't understand me. But notice how it recognizes that the error in question is a command error. Let's provide an override for this. Let's say that every time the system hears add trucker, we want it to interpret it as add series. Now let's try add trucker again. Notice this time that when we get an error, it's not a command error any longer, it's a data error. That means the system has accepted add trucker as a command and is expecting, based on the grammatical structure, a data element. Let's prove that by giving it one. Add trucker Canada. The system is now accepting add trucker as add series, so when we type add Canada, we get a new series, Canada. Let's try something different. Let's try adding, say, add top trucker. This time we get a parameter error. That's because add top is a legitimate command, but the system expects it to be followed by a numeric parameter, such as add top 1 or add top 2. Let's provide a replacement for trucker as a parameter. We'll just say it's replaced with 2. Now when we type in add top trucker salesperson, we get, because of the substitution, top 2 salesperson. This override mechanism is very effective, but it doesn't get used that often. Look again at the number of overrides currently in place. And I'll remove the 2 we just added. So if you scroll up and down here and you recount these, you come to about 50 of them. But that's with me using every nook and cranny of the system, and I haven't had to add a new override in months. Our vision is that a new user will simply read a number of test phrases presented on screen, and based on that test, the system will create about 95% of the overrides he or she will ever need. A couple of last points. If you need to know which commands you can issue, you can use the show commands command. This is context sensitive, so it'll change depending on the screen you're in, and it basically gives a description of the command, the parameters it accepts, and a fuller description of the command. So even if you don't know anything about the system, no matter what screen you're in, you can use this command dictionary to tell you what it is you can say to the computer. You can also view all possible data elements using the show data command. So now this shows you all the data elements in the database, which of course vary from one customer to another. In this case, we're looking at the list of customers, but we could just as easily look at the list of, say, products, etc. And again, this helps the user to know what they can and can't say to the system. The second last topic I'd like to address is how this system compares to other voice control or natural language systems. We don't have time to go through all the competitors, so I'm just going to talk about Power BI, as it has many traits shared by Watson Analytics, Google Analytics, and presumably others. The first major difference is the approach that Power BI uses for voice control. It utilizes Cortana's search engine capabilities and simply adds Power BI tags to the body of searchable content. This forces your commands to compete with the whole universe of possibilities. As mentioned previously, our system does not do this. It uses the phonetic pattern returned by Google's Speech API to search the finite world of the client's database. That's a huge difference. With Cortana, I get frustrated all the time. With our system, it rarely misunderstands me. With Power BI, there is no voice interaction with the on-screen data elements. The role of Cortana is to help you find the correct dashboard. It does allow you to tack a few parameters onto the end of your request, but once you arrive at the dashboard, you have to interact with it almost entirely via your keyboard or mouse. There is no independent control of individual data series inside the same interface, meaning no custom comparisons like I showed you between an individual salesperson and, say, the top 3 salespeople. There is no preservation of context as you move from one dashboard to the next. Every request is an independent request, which makes it difficult to follow a natural path of inquiry, as you saw me do when I was investigating the problems with the Turing 1000. There is also a fundamental difference in philosophy. Power BI, Watson, and Google Analytics all rely on AI to automatically dig up observations, most of which are irrelevant. We can do that as well, but we mostly rely on the human mind to drive inquiry, which eliminates the irrelevant. Finally, the big 3 are mostly template driven, whereas we have the full power of Dundas BI's development platform and extensive APIs at our disposal. This means we have no limits on what we can code. Okay, last subject, the current state of our technology. At this point, everything works in the lab. There are no more issues for us to resolve when working with test data. What we want to do now is move this technology into the field where it can be properly battle tested against the real demands of real users. We'd like to tackle a project with good future potential, as we believe our technology will revolutionize the target system and open new possibilities. To this end, we're actively seeking a customer or partner who wants to go on this journey with us. That concludes our presentation, so we'll now open the floor to questions.